This video will explain the rule of existential quantifier out. So like the rule of universal quantifier out, with the rule of existential quantifier out, we're going to be instantiating the formula. So we remove the quantifier and then we replace the x's in the formula with a letter. And it's still going to be one of the letters A through V. However, there's a restriction on existential quantifier out, which is that the letter we use to instantiate it must be a letter that is new to the proof. A letter it does not occur in the conclusion, in any premise, or in any previously derived line. And the reason for this is, well, so with universal quantifier out, so we have this, if we have the statement for every x, if px, then qx. Well, then that's true of everything. So if A has the quality P, then so does Q. If B has the quality P, then so does Q. So it doesn't matter what letter we replace it with. However, the statement, there exists an x, px, and qx, is just saying, look, there's at least one thing that has the qualities, both the qualities P and Q. But we don't know what that thing is. So we have to be careful that we don't make an assumption that it's a thing that we're already talking about. So basically the reason why it needs to be a new letter is because that makes it a dummy letter. It's not really standing for anything in particular. It's just saying, well, sort of what if A has the quality, A is the thing that has the quality P and the quality Q, and then we see what follows from that. So I will illustrate how this works with a proof. So to start this off, we noticed that the conclusion is a negated universal statement. So overall, we're going to need to get this conclusion by a reductio proof, by a dash-in proof. So we're going to get the conclusion for all x, it's false that for all x, if ox, then wx, by dash-in. So we need to start out with the provisional assumption of for all x, if ox, then wx. And so we're going to need an assumption dependence column. So all the premises depend on themselves, and so does the provisional assumption. Okay, and then we need to instantiate formulas. Now we always want to instantiate our existential formulas first. And the reason for that is because of the restriction on existential out. If we instantiated either of the two universal formulas first, let's say we did line 2. So if we did IA, then not WA by one universal out. Well, then when we went to do the existential, well, we couldn't use the letter A now because A wouldn't be new to the proof because we already would have it on a previously derived line. So we'd have to use some other letter, like say B. But then the formula IA arrow not WA, and then this IB, they can't interact because they're not the same thing. So we can't, do IB by ampersand out on line 5. So this would be by 1. This is by 2 universal. This is by 1 existential out. And then we can't get WA by arrow out from lines 4 and 5. That's because IA and IB are not a match. So what we want to do instead is we want to do the existential formula first. So IA and OA by 1 existential out, and that'll depend on 1. And now when we go to instantiate the universal formulas, we can use the letter A, no problem. So it really just matters what order we do things in. Send out is by 2, universal out, depend on 2. So we're just going to instantiate everything. That's by 3, universal out. And now we're looking for a contradiction. So I'll do IA from 4 ampersand out. That will depend on 1. And that will give me not WA by 5, 7, arrow out. And then I'll get OA by 4 ampersand out. I'm going to need some more room here at the bottom. So let's see, 5, 7, so that depends on 1 and 2. And then the 4 and out, so that depends on 1. And now I get WA from 6, 9, arrow out. And that's going to depend on 1 and 3. And then a line 11 will be my contradiction, WA and not WA. And that's by 10, 8, ampersand in. So that will depend on 1, 2, and 3. And then line 12 will be my conclusion. It's false that for all x, if OX, then WX. And that's by 3 through 11 dash in. And that'll depend on 1 and 2.